I'll cancel it, okay? Alright. I have to finish inverse trig business today, no matter what. So the first thing that I want to point out that I said a couple of times, but maybe I should just focus on that once and for all. F inverse of x is y if and only if f of y is x, right? So that means the inverse f takes x to y if f takes y back to x, right? We all know that. The inverses, I have a pair of functions which are inverses, f inverse, they do the opposite of each other, right? Now, the statement that I am making here is that f, the function f, has a vertical asymptote at x equals to a if and only if the inverse of f has a horizontal asymptote at y equals to a, and vice versa. What do I mean by vice versa? If f inverse has a vertical asymptote somewhere, then the function f will have a horizontal asymptote somewhere. Am I making sense? The statement is f has a vertical asymptote at x equals to a, right? Then the function f inverse will have a horizontal asymptote at y equals to a. Now, why is that the case? What does it mean to say that f has a vertical asymptote at a? What does it mean? If I have a vertical asymptote at a, right? So let's say a is right here. This is my y-axis. Well, this is the vertical line at x equals to a, let's say. And what does it mean to say that I have a vertical asymptote? It means that on the left side of a or on the right side of a, the function goes to infinity or negative infinity, right? That's the meaning of vertical asymptote. I have a vertical asymptote at x equals to a means that on the right side of a or on the left side of a, the function goes to infinity or negative infinity, right? The graph of the function gets closer and closer to the vertical line, goes to infinity or negative infinity. So that means the function f, so think about this, the function f has a vertical asymptote at a, right? It means that the limit of f at a from the right side or the left side is infinity or negative infinity. Am I making sense? Is everybody okay with that? So maybe I can make a picture here. So let's say this is the x-axis, y-axis, and let's say this is the vertical asymptote here. So this is a here. F as a vertical asymptote means either on the left side of f, on the left side of a, the function f goes to infinity, or on the right side of a, the function goes to infinity, right? Either one of them, or maybe both of them can occur, or maybe it goes to negative infinity, right? Instead of positive infinity, it may be going to negative infinity. So the function f has a vertical asymptote simply means that the function goes to infinity or negative infinity near a. Near a, the function blows up. Negative infinity, positive infinity. Now, what am I claiming? I'm claiming that f inverse has a horizontal asymptote, right? F inverse has a horizontal asymptote at y equals to a. What does it mean? What does it mean to have horizontal asymptote? What does it mean to say, if I make another graph here, what does it mean to say that I have a horizontal asymptote at y equals to a? If I say y equals to a is a horizontal asymptote, what does it mean? It means that either as x goes to infinity, the graph of the function function goes to a, the limit of the function is a, as x goes to infinity. As x goes to infinity, the function approaches a, or as x goes to negative infinity, the function approaches a, right? So when you have a horizontal asymptote at y equals to a, it means that either as x goes to infinity, the function approaches a, or as x goes to negative infinity, the function approaches a as well. So keeping that in mind, let's see why the f inverse has a, why does f inverse have a horizontal asymptote array. Can you tell me what this limit is? We are assuming the limit of f of y as y goes to a is plus or minus infinity. My question is, what's the limit of f inverse of x as x goes to plus or minus infinity? Well, notice here, f and f inverse are inverses. So what is f inverse of x? Remember, I took f inverse of x is y. So keep this notation in mind. Then what is f inverse of x? Well, let me not even write that, sorry. Note that this guy is y, and note that this guy is f of y, right? Am I correct? So basically we are saying, what's the limit of y as f of y goes to plus or minus infinity? You get that? Remember, these are the limit of f of y as x goes to plus or minus as y goes to a is plus or minus infinity. Now I'm looking at the limit of f inverse of x as x goes to plus or minus infinity, but x is f of y, and f inverse of x is y, right? So what's the limit of y as f of y goes to plus or minus infinity? So we are asking, what's the limit of y? What's the limit of y as f of y goes to plus or minus infinity? Right? You realize that? We are asking, what's the limit of y as f of y goes to plus or minus infinity? We are basically doing the opposite of that, right? We are asking the opposite question. So it's got to be what? It's got to be what? This limit has to be a, right? I mean, even more simply, these two functions, f and f inverse, they are doing the opposite of each other, right? So, what's the difference? If you have AB on the graph of f, then BA is on the graph of f inverse, right? So, you're saying that you have the point AB as you have the point xy on the graph of f, and you have yx on the graph of f inverse. So as x goes to a, y gets closer and closer to infinity. I shouldn't say that. I should be saying it approaches infinity. And then at the same time, what is happening to the inverse? Well, f inverse of x is going to go to a. Is that making sense? Is everybody okay with what I just said? We have been using that I have used it. I said it a couple of times, but I didn't tell you exactly what's going on. So I'm going to use it again today. Inverse secant function, arc secant, secant to the -1 of x, whichever you want to call it. I've given you the handout on secant inverse before, right? You can look at that. I gave you the graph of the secant inverse in my handout, so you don't have to draw it right now. You can just make notes on that paper. Okay, so what I did is that I basically, first of all, when I drew this yesterday, first thing that I did is I drew the graph of secant. But remember, secant function is a periodic function, so it's not one-to-one. So once again, what we have been doing was that we are going to take a restricted domain of the secant function where it is one-to-one. However, it doesn't lose any of the range values. Okay, am I making sense? So we are picking a domain for the secant function where it is one-to-one, but it still has the same range. It still has the same range. Well, one such choice is that I am looking at the graph of secant from 0 to pi over 2. I'm looking at the graph of secant from 0 to pi over 2. So here is 0, and here is pi over 2. Okay, looking at the graph of secant between 0 and pi over 2. That's the green part. So the green parts are the graphs are for the secant function. Okay. If you don't know how to obtain the graph of secant for now, just believe me. That's the graph. The graph of secant from 0 to pi over 2 is the green curve that I have on that interval. And then I am looking at the graph of secant from pi to 3 pi over 2. So from pi right here to 3 pi over 2, I am getting the another part of the graph of secant. Okay, is everybody clear? Now let's look at the graph of secant between 0 and pi over 2. Between 0 and pi over 2, the graph of secant is what? Increasing, concave up, has a vertical asymptote at pi over 2. That vertical asymptote here is at pi over 2. Okay? Now, let's look at the graph of secant from pi to 3 pi over 2. Well, it has a vertical asymptote at 3 pi over 2, concave down, decreasing, right? Now, what's the range? What's the range of secant then? The range of secant is negative infinity to negative 1, 1 up to infinity. Notice that pi over 2 is not in the domain of secant. 3 pi over 2 is not in the domain of secant. 0 is in the domain, pi is in the domain. Everybody is clear? 0 is in the domain, pi is in the domain. At pi, what's the value of secant? Negative 1. At 0, the value of secant is 1. Is everybody clear? Now, after I drew the graph of secant, then I drew the line y equals to x. Why? Because I know that the graph of the inverse secant will be a reflection of the graph of secant across that line, right? Okay, now I want to draw the graph of the inverse. Now, first of all, the green curve is the graph of secant, right? Is that 1-to-1? Is that 1-to-1? Well, it satisfies the horizontal line test, right? So it is 1-to-1. It has an inverse, and I want to know what's the graph of that inverse. First of all, you have a point. First of all, you have a point on the graph of secant. Let's first think about what is the reflection of the secant curve between 0 and pi over 2. Well, between 0 and pi over 2, notice that I have the point 0, 1, right? 0, 1. What would be the reflection of that? 1, 0. So I get this guy, right? You agree? 0, 1. The reflection of 0, 1 would be 1, 0. So I drew that point first. And then what did I do? Well, notice that the graph of secant between 0 and pi over 2, it has a vertical asymptote at pi over 2. Because it has a vertical asymptote at pi over 2, that means that the inverse will have a horizontal asymptote at pi over 2. So I have the line horizontal asymptote at pi over 2. Right? Everybody's clear? So I drew the horizontal asymptote at pi over 2. I know the point 1, 0 is on the graph of inverse secant. Now, the secant function between 0 and pi over 2 increases or decreases? Increases. If a function increases, the inverse will also be increasing. Okay? So if I look at the inverse of the secant function between 0 and pi over 2, whatever the inverse is, it is also increasing. So what's the range for the secant curve between 0 and pi over 2? What's the range of the secant curve between 0 and pi over 2? It's 1 up to infinity. So you know that the domain of the reflection would be 1 to infinity, right? 1 to infinity. So I know that the function increases, goes from 1 to infinity, and it has a horizontal asymptote. The only choice I have is that pink term, right? That's how I thought about it. Okay. All right. So I got that part. So then, now let's think about what would be the reflection of the graph of secant between pi and 3 pi over 2. What would be the first thing I do? Well, I am going to think about what would be the reflection of the point pi negative 1. I have the point pi negative 1. What's the reflection of that? Negative 1 pi. So I get this point, negative 1 pi. That's the first thing that I do. The second thing is, again, I have a vertical asymptote at 3 pi over 2. Therefore, I have a horizontal asymptote at 3 pi over 2 for the secant inverse. So I drew the horizontal asymptote at 3 pi over 2. Finally, now I am thinking that between pi and 3 pi over 2, the secant curve is what? Yes, it is decreasing. The secant curve is decreasing in that, right? So I know that its inverse, when you look at increasing, decreasing behavior, you read the graph from left to right, right? Now, what did I say about the inverse? The inverse will also be decreasing. So from left to right, the inverse is also decreasing up to the point negative 1 pi. Okay? But it has a horizontal asymptote at 3 pi over 2, so the only possibility is what I drew. Decreasing, I have a horizontal asymptote there, right? That's the only possibility. Is that making sense? Is everybody okay with that? So that's how I can get the graph of the inverse secant function, just by looking at the graph of secant on the restricted domain that we picked. Again, we picked the restricted domain for the secant to make it 1-to-1. Is there any other way of making this? Is there any other way of coming up with this, with the graph of secant inverse? You bet. Another way is, look at secant inverse, look at the derivative of secant inverse. I'm going to show you how to find the derivative of secant inverse in a bit. You can find the derivative of secant inverse and then ask yourself, when is the derivative positive and negative? And that's going to tell you when it's increasing and decreasing. And then you can take the second derivative, it's going to tell you about the concavity. And then you can look at the extreme behaviors, whether you have horizontal asymptotes, vertical asymptotes, and so on, right? And then you can come up with the graph. But I don't want to do that analysis, because you can just look at the graph of secant and understand what's going to happen for the graph of inverse secant. Is that making sense? So once again, what's the meaning of secant inverse? Secant inverse of x, so I'm reading right here, secant inverse of x is y if and only if secant of y is x. Okay? So here is where I'm looking at. Secant inverse of x is y if and only if secant of y is x. And then what would be the domain of secant inverse? What's the domain of secant inverse? What is the domain of secant inverse? The domain of secant inverse would be the range of secant, and the range of secant is negative infinity to negative 1, positive 1 to positive infinity, right? So the entire real line except the interval between negative 1 and 1, right? But remember, 1 and negative 1 are included in the domain. 1 and negative 1 are included in the domain. Okay, what's the range? What's the range of secant inverse? What's the range of secant inverse? The range of secant inverse is what? The restricted domain of secant that we picked. The restricted domain of secant that we picked. And what domain did we pick for the secant to make it 1-to-1? 0 to pi over 2, pi to 3 pi over 2. That choice looks odd, right? But there are other choices. Could I have made other choices? Yes. In fact, if you look at many of the texts, they actually make a different choice. And let me tell you that. Some textbooks, instead of picking the interval from pi to 3 pi over 2, they are going to pick the interval from pi over 2 to pi. So between pi over 2 to pi, this is how the graph of secant looks like. Between pi over 2 to pi, the graph of secant looks like the red curve. Okay, that's a valid option to take. Okay, and actually a lot of the textbooks will make that choice. When I was a student, that was the choice that we made in our class. Okay, you might say, well, what's the difference? Well, I'm going to point out when time comes why your textbook makes this choice. When you make this choice, the derivative looks better, a little bit more good looking than the other. However, you do give up something when you make this choice, and I'm going to point that out later. Okay, so this is sort of like you're giving up something for something else. Okay, and I'm going to show you. I'm going to talk about that in a bit. Now, so we are going to make that choice. Your textbook made that choice, so that's why I'm sticking to it. Otherwise, when I assign homeworks, if I make the choice, if I take the domain to be from pi over 2 to pi, then whatever answer I am expecting will not be the same as in the back of the book. In any case, now think about what's the derivative of secant inverse. Over and over again, you have to think about what we have done for sine inverse, tangent inverse, cosine inverse. If you think about that, all the ideas are the same. We are not using any new ideas for secant inverse or tangent inverse. Once you know how we all the items that I went over for sine inverse, once you understand them, you're pretty much done for the other ones. And I am seriously saying that if you know how they played out, you know how to do these things as well. Let's see why. How do you find the derivative? Anytime I have a pair of inverses, if I know the derivative of one of them, I can find the derivative of the other by using what? Implicit differentiation, right? So you take y to be secant inverse of x, and then what is secant of y? Secant of y would be x, right? You agree? Now, you take now the derivative of both sides with respect to y. On the left hand side, what are you going to end up with? What's the derivative of secant y? Secant y tangent y. Is that it? Very good. Y prime and then 1, and then I get y prime, which is 1 over secant of y times tangent of y. But do I know what secant of y is in terms of x? Secant of y is exactly x. So I get x times tangent of y. But I also want to express tangent of y in terms of x. I also want to express tangent of y in terms of x. Now there are two ways. One way would be I can do it algebraically. I can replace tangent of y by the root of secant squared y minus 1. Maybe I'm going to show you that some other time. But you can replace tangent of y. Remember, tangent squared is secant squared minus 1. So that means tangent of y would be root of secant squared minus 1. I could have done that, but I'm not going to do that. Instead, I'm going to use reference triangles as before. So there are two possibilities, right? One is that, by the way, let's see how much trigonometry you remember. If x is positive, remember, what is y? Y is secant inverse of x. So y is an angle. Secant inverse of x is giving you an angle where? What's the range for secant inverse? 0 to pi over 2? pi to 3 pi over 2. So secant inverse of x is giving you an angle either in the first quadrant or in the third quadrant. You agree? Now, if you know that x is positive, what's the position of the angle y? If x is positive, think about the graph of secant. If x is positive, well, you don't have to know the graph of secant. I mean, in the first quadrant, which trig functions are positive? All of them. Second quadrant, sine and cosecant. Third quadrant, tangent, cotangent are positive. Everything else is negative. Fourth quadrant, if you have an angle in the fourth quadrant, cosine and secant are positive. Everything else is negative. So if x is positive, secant of y is positive, then y would have to be in the first quadrant. Okay, so that's one possibility, that y is in the first quadrant. In that case, what's the reference triangle? Well, notice that secant of y is x, which is the same as x divided by 1. And what is secant? Hypotenuse over adjacent. Well, what should I pick for hypotenuse? X. I should pick, for the adjacent, I should be picking 1. By Pythagoras, what is the opposite? X squared minus 1? Root of that, right? So from there, do I see what is tangent of y is? What is tangent of y? Tangent of y is opposite over adjacent, so what is that? Yeah. So I get that. Now you might say, what if secant inverse of x is giving you an angle in the third quadrant? Remember, secant inverse of x is giving you an angle in the first quadrant, 0 to pi over 2, or pi to 3 pi over 2, which is in the third quadrant. In that case, the angle y would be here. In that case, what are you going to pick for the adjacent and the hypotenuse? Well, in the third quadrant, secant is negative. Remember that? So in the third quadrant, secant of y is negative, which would mean that x is negative. If x is negative, remember hypotenuse is always positive. So I have to take the hypotenuse to be negative x. Let me say that again. If y, the angle y is in the third quadrant, secant of y is x, right? Secant of y is x. In the third quadrant, secant is negative. So secant of y is negative, which means that x is negative, right? If x is negative, negative x is positive. Hypotenuse needs to be always positive. So that's why I put negative x. And what should be the adjacent then? Because I know that secant of y is x divided by 1, so the adjacent has to be negative 1. And then the opposite is still what? The opposite is still root of x squared minus 1. So if you look at it, you see that still, oh no, opposite is not positive root of that, right? Opposite would be the negative root of that, because it's on the other side of x-axis. So then, once again, if I look at the tangent of y, I still get the same answer. Am I making sense? I still get the same answer. Now, all that I did with the circle, it is just equivalent if you just consider one triangle. So that is, if you just assume that the angle is between 0 and pi over 2, and then if you make just one triangle, you're going to take the hypotenuse to be x, adjacent to be 1, and the other side would be this. And if you just draw that triangle and say that the secant of y is x, means the hypotenuse should be x, adjacent to be 1, and the other side by Pythagoras would be a root of x squared minus 1, and then tangent of y is blah. Okay? It's most of the time, most of the instructors who teach calculus, they will not bother drawing the circle and talk about what happens when x is positive and negative, y is in the first quadrant or the third quadrant, because at the end of the day you get the same answer. Am I making sense? So why if you have a chance to be nice to the students, be nice. Okay, so that's why most people would be doing the triangle. Am I making sense? But at least I wanted to point out for once that the appropriate thing to do is to go back to the circle, see what's happening. Of course, at the end of the day, it is enough to just look at one triangle, and whatever result you get from there is correct. Is everybody okay? And we are going to do that a lot in the coming days. Okay, so the derivative that we get at the end is what? Let me make sure I highlight that. This is the derivative I got for the secant inverse of x. Okay. Now, right away, what's the integral of 1 over x root of x squared minus 1? What is that? What is the integral of 1 over x root of x squared minus 1? Yeah, it's the derivative of secant inverse. So you just get the secant inverse function. All right. Is everybody clear so far? Now, I want to do a domain problem as usual. That's what we did with the other one. So what's the domain of secant inverse? Now, in the handout that I gave you, there is a problem. I forgot the problem number, maybe 12, if you have it in front of you. I think I said find the domain of secant inverse of 5x plus 2. Is that correct? Find the domain of secant inverse of 5x plus 2. 13, okay. But instead of that, I'm going to use 2x plus 1 and keep that for you to do, okay? What is the domain? The question is, what's the domain? So let's remember what's the domain of secant inverse of x. Secant inverse of x, what's the domain for that? What's the domain for secant inverse? Absolute value of x is larger than 1 way to say that. Larger or equal to 1. In other words, either x is less than or equal to negative 1 or x is larger or equal to 1, right? That's another way of saying it. Remember this, the domain of secant inverse is the range of secant, and the range of secant is either negative infinity to negative 1 or 1 to infinity, right? Am I making sense? That's the range of secant. How do I know that if you for some reason forget what's the range of secant, how can you come up with that? Remember, secant is 1 over cosine, right? Now, what do you know about cosine? Cosine is between negative 1 and 1, and it takes on the value 0, right? So when you take 1 divided by cosine is between negative 1 and 1. So what is 1 divided by something between negative 1 and 1? It's always larger than 1 or less than negative 1, right? Am I making sense? When you are near 0 then, when cosine takes on 0 at pi over 2. So when you are near pi over 2, cosine 0 blows up, right? Am I making sense? So but just look at 1 over cosine. Because cosine is less than, let me maybe say it here, cosine of x is less than or equal to 1, right? And it is greater than or equal to negative 1. So 1 over cosine, when you take the reciprocal of it, right? When you take the reciprocal of it, what do you get? Well, forget about this thing for now. You just notice that I'm going to be getting this, right? Is that making sense? Is that okay? And what's going to happen on the other side? Yeah, it is going to be less than, right? So it means that secant is either bigger than 1 or less than negative 1, right? Is that right? Okay. So in any case, all I wanted to say that if you forget what's the range of secant is, you can come up with it by looking at 1 over cosine. Now, that's the domain of secant inverse. So how do I come up with the domain of secant inverse of 2x plus 1? What do I want? I want 2x plus 1 to be either less than negative 1 or I want 2x plus 1 to be greater than 1, right? Either way. Either I want 2x plus 1 to be bigger than 1 or less than negative 1, because otherwise you cannot apply secant inverse. From the first, what do I get for x? X is less than or equal to? What's the solution of the first inequality? No, you're going to subtract, you're going to negative 1, right? Or in the second one, you're going to get 0. That's where you're getting 0, yes. So x would be greater than or equal to 0. So what's the domain? Well, I think you should probably draw the real number line to make sure that you see what the domain is. Here is say negative 1, here is 0. And the domain is either x bigger than 0 or x less than negative 1, right? So what's the domain? The domain is, actually let me write it here. Domain is negative infinity to negative 1. Negative 1 is included, right? And 0 to infinity. You agree with that? That's the domain of secant inverse of 2x plus 1. Is it clear? Is everybody okay? Alright. Next thing. What is cotangent of secant inverse of 3? What is cotangent of secant inverse of 3? How do I find them? Just like I did for, remember last time we did, I think, cosine of tangent inverse or something. So here, as usual, you take theta to be secant inverse of 3, which tells you secant theta is 3, and we know that secant is hypotenuse over the adjacent once again. Now, so what is cotangent of secant inverse of 3? It is cotangent of theta, right? Because I took theta to be secant inverse of 3. So what is cotangent of theta? Now notice that secant of theta is positive. Now theta, by definition of secant inverse, theta is in the first quadrant or the third, but secant is positive, which means that it's in the first quadrant. So theta is here. Theta is here, and that's the reference triangle. What's the hypotenuse? 3. What is the adjacent 1? So what is the opposite? It'll be radical 8, which is 2 root 2. So I get cotangent theta would be, cotangent is the opposite over tangent, so it'll be adjacent over opposite. Adjacent is 1, opposite is root 2 over 2. Now once again I want to say, you don't have to draw the circle, as long as you draw a right triangle and label your angle theta and say that hypotenuse would be 3, adjacent would be 1, opposite would be root of 8, you're fine. Okay? So I could have just done that. Alright. Any questions on that? I'm almost out of time, so I'm not going to do the other parts in my handout. You can go over the other parts. I think they are easy enough. Or watch my videos on tangent inverse and sine inverse, you'll know what to do. What I want to do now, though, is wrap up my discussion on the inverse trigonometric functions here. So some remarks that I want to make. First of all, what is the graph of cosine inverse? Cosine, I think I forgot to write down the cancellation laws for secant. Secant of secant inverse of x is x. Secant inverse of secant of x is x. Same way for cosine, we have those. What's the derivative of cosine inverse? Negative 1 over root of 1 minus x squared. And notice that the derivative of cosine inverse is exactly the same as derivative of sine inverse, except for the negative sign. Okay? And the graph of cosine inverse is the pink one. The graph of cosine is the green one in this picture. You guys did this in the quiz. So I also wanted to show you the graph of cosecant and cosecant inverse. And the green curve is the graph of cosecant. The pink curve is the graph of cosecant inverse. And the derivative of cosecant inverse turns out to be -1 over root of x squared minus 1. And I'm not even going to give you enough time to look at it. If you want to look at it, go to the video and pause it and see and what that is, okay? But you can come up with this graph exactly the way I came up with the graph of secant. The last thing I want to say, just like tangent inverse, I also have cotangent inverse. Here, green one is the cotangent inverse, green one is the cotangent, pink one is the cotangent inverse. The derivative of cotangent inverse is -1 over 1 plus x squared. Now, all I require you to know is sine inverse, cosine inverse, tangent inverse, secant inverse. You don't have to know cotangent inverse or cosecant inverse. You don't have to know those two. One more remark, if you give me one minute. Cosine inverse of x turns out to be the same as pi over 2 minus sine inverse of x. Tangent inverse of x turns out to be the same as pi over 2 minus cotangent inverse of x. You can prove them very, very easily. Secant inverse of x is equal to cosine inverse of 1 over x when x is larger than 1. And secant inverse of x is 2 pi minus cosine inverse of 1 over x if x is less than -1. You see that I had to break up in this formula for secant inverse. I can write secant inverse in terms of cosine inverse. I had to break up the formula here. The reason I have to break up is the way I chose my interval. Remember I said when instead of choosing from pi to 3 pi over 2, if I made the choice from pi over 2 to pi for secant, then I wouldn't have to break up my formula here. But then my derivative would be uglier. In what sense? Well, the derivative of secant is what? The derivative of secant was 1 over x times this, right? If you make a different choice for the domain of secant, that is, take the domain from pi over 2 to pi, you have to put absolute value sign around x. So you made your derivative look better, but then your formula for writing secant inverse in terms of cosine inverse got worse. However, we are not really going to use these formulas. So we want to make the thing that we are going to use look better than the things that we usually don't use. Is that making sense? All right, so I'm going to see you tomorrow.
Just one question like normal.
The quiz tomorrow would be on tangent inverse function. I am going to give you 1 or 2 problems from the handout.
Probably wonder